Hi everyone. So today we'll continue our discussion on basic stress analysis. Before talking about the contents of today, let me give you a review on lecture 1. So in previous lecture, I gave you some overview of this course and tried to highlight the difference between freshman physics and ME 231. So back in freshman physics, you only considered like rigid body and you focused on like a force and torque, those vector quantities, and also including the scalar quantity called pressure. So without learning ME231, you can obtain normal force, torsion torque T, shearing force V, and the bending torque moment M. So you can get these four quantities only from freshman physics. However, in our ME231 lectures, starting from this four reaction force and torque, we will obtain either normal stress or shear stress, and out of shear stress and normal stress, using material property called stiffness, we're going to obtain strain, normal strain, and shear strain. And out of this strain information, we'll obtain deformation of the structure. And also, out of this maximum normal stress and maximum shear stress, by comparing this with material property called strength, we can define whether a structure is mechanically reliable or not. Having highlighted the difference between freshman physics and ME231, I went over to review on statics and give you a example problem and try to explain the step-by-step procedure to solve any statics problem. So what you have to do first is you have to identify number of degree of freedom. It can be 3 from translation along XYZ and 3 from the rotation about XYZ axis. Then you can find and specify all unknown external forces for the entire structure, and you can write down the mechanical equilibrium equation, and you're gonna find like n number of degree of freedom equations. And if this degree of freedom turns out to be smaller than number of unknowns, you have to repeat this for individual segments, and that's what we have done for these structure, right? So we obtained like a road and boom, and there was 30 kilonewton, and we solved this problem according to this 1 2 3 4 procedures. Then we discussed about a smarter way of solving this problem. The secret is to identify two force members out of the structure. So for example, for this example problem, if you identify that BC is two force member, and you can imagine some line connecting this two force location, and the force should be acts on parallel to this red dotted line. Okay, that's the implication of a two force member. So that without defining like a two unknowns like a force horizontal and force vertical, you can just immediately say that okay, the first direction must be aligned with this the line connecting these 2 points, and you can reduce the number of unknowns, and you can solve statics problem like easily and efficiently. Okay, so these are the concepts we covered in previous lecture, and hopefully you do repeat the lecture note by yourself, and so that you have 100% understanding on what I have covered in lecture 1.